Mechanics, kinematics, Newton's laws, gravitation, work, energy, and power. Mechanics. Mechanics is a fundamental branch of physics that deals with the study of motion and the forces that cause it. It encompasses various subtopics, including kinematics, the laws of motion, gravitation, and the concepts of work, energy, and power. Kinematics. Definition: kinematics is the branch of mechanics that describes motion without considering the causes of motion, i.e., forces. It focuses on the mathematical description of objects in motion. Key equations: distance, speed, and time. Distance, d, is the length of the path traveled by an object. Speed, v, is the rate of change of distance with respect to time. Time, t, is the duration of motion. Equation: distance equals speed x time, d equals vt. Velocity. Velocity, v, is a vector quantity that includes both magnitude, speed, and direction. It represents the rate of change of displacement with respect to time. It can be positive, speeding up, negative, slowing down, or zero, constant velocity. Equation: acceleration equals change in velocity, time, a equals delta v, delta t. Newton's laws of motion. 1. First law, law of inertia. An object at rest will remain at rest. And an object in motion will remain in motion at a constant velocity unless acted upon by an external force. 2. Second law, F equals ma. The force, F, applied to an object is directly proportional to the mass, m, of the object and the acceleration, a, it experiences. This relationship is expressed as F equals ma. 3. Third law, action and reaction. For every action, there is an equal and opposite reaction. When one object exerts a force on another object, the second object exerts an equal force in the opposite direction. Gravitation. Definition: gravitation is the branch of mechanics that deals with the study of the gravitational force of attraction between objects with mass. Key equations. Universal law of gravitation. Every object with mass attracts every other object with mass through a force called gravitational force. The force, F, is directly proportional to the product of the masses, m1 and m2, and inversely proportional to the square of the distance, r, between them. Equation: F equals g, m1 m2, r squared. Weight. Weight, W, is the force with which an object is pulled towards the center of the Earth, or any other celestial body. Weight is calculated using the formula, weight equals mass, m, x gravitational acceleration, g. Equation: weight equals mg. Work, energy, and power. Definition: work, energy, and power are concepts that describe the transfer and transformation of energy in various physical processes. Key equations. Work, W. Work is done when a force is applied to an object, causing it to move a certain distance against the force. The work done, W, is given by the product of the force, F, the displacement, d, and the cosine of the angle, theta, between the force and displacement vectors. Equation: work equals force x displacement x cosine theta. Kinetic energy, K. Kinetic energy is the energy possessed by an object due to its motion. The kinetic energy, K, of an object with mass, m, and velocity, v, is given by the formula, K equals 0.5 mv squared. Potential energy, Pe. Potential energy is the energy associated with an object's position or condition. For objects near the Earth's surface, gravitational potential energy, Pe, is given by the formula, Pe equals mgh, where h is the height above a reference point. Power, P. Power is the rate at which work is done or energy is transferred. The power, P, of a process is calculated by dividing the work, W, by the time, T, it takes to perform the work. Equation: power equals work, time, P equals W/T. Understanding these fundamental principles of mechanics is essential for analyzing and predicting the behavior of objects in motion, as well as the forces that influence them. These concepts play a crucial role in various scientific and engineering applications.